Hi, grade 8. This is the math lesson for lesson 3-4, page 117, numbers 10 through 36 all, and 43 through 46 all. Might seem a little bit repetitious, but today's lesson is an awful lot like yesterday's. Yesterday, you were using inverse operations to solve addition and subtraction problems. Today, you're using inverse operations to solve multiplication and division problems. There will again, in the directions, be listed two properties to think about. One of them is the multiplicative property of equality, and one of them is the divisional property of equality. They're mentioned on, let's see, what page number is that? Oh, top of 117 and bottom of 115. But basically, how does this all work? If I have a problem like the following, negative 16 times x equals a positive 96, and I want to figure out what x is. How do I solve for x? Well, I'm going to write out the problem, and I'm going to think to myself, what is x attached to? X is attached to this negative 16 by multiplication. What's the opposite of multiplying by negative 16? Dividing by negative 16. I'm going to do it to both sides of the equation. And in this case, I get x equaling whatever this is, which happens to be negative 6. What did I just use? According to your textbook, I just use the division property of equality to solve that equation. Or in other words, I divided both sides of the equation by negative 16. Because dividing by negative 16 is the opposite of multiplying by negative 16. Next problem. What if I have the following? X divided by negative 4 equals negative 12. And somebody says to me, find the value of x. Well, again, I'm going to rewrite the problem, and then I'm going to think about what's going on here. What is my variable x attached to? It's attached to this negative 4 by division. What's the opposite of dividing by negative 4? How about multiplying by negative 4? And I do it to both sides of the equation. And when I do it, I get an x value of positive 48. Because negative 12 times a negative 4 is a positive 48. Let's try a couple word problems. What if I said Miss Mackenzie opened a restaurant, and her restaurant, every meal has the same price. Every single meal costs $10, no matter what you buy. You buy a lasagna dinner, $10. You buy a cheeseburger, $10. You buy meatloaf, $10. And let's say one day, Miss Mackenzie's restaurant brings in $1,420. $1,420. How many meals did she serve that day? Well, each meal is $10 a piece. She brought in a total of $1,420. What kind of math problem could we solve with this? How about 10 times an unknown amount of meals gets me to 1,420? An unknown amount of meals times 10 gets me to $1,420. So, how am I going to solve this? Well, let's put a variable in the spot of the question mark. We'll call it B as in boy. And let's say to ourselves, okay, what's the opposite of multiplying by 10? We're going to divide by 10. And we're going to do it to both sides of the equation. We get a B value, in this particular case, equaling 142. Now, whoops, it's off the screen. Now, what's going to be the label on that? Remember, this is the amount of money she brought in. This is the amount she's charging per meal. So this must be the amount of meals she served. She served 142 meals to customers. Okay, let's try with a different one. let's imagine Mr. Rael decides to go out for a drive in his pickup truck. And his pickup truck ends up going 620 miles. And Rael knows that his pickup truck gets 20 miles per gallon. Now, another way to say 20 miles per gallon is to say he gets 20 miles of traveling for every 1 gallon of gas. So if he puts in a gallon of gas, he's going to travel 20 miles. Now the question is, in this particular case, how many gallons of gas would Rael need to accomplish this trip? Wouldn't that be an unknown amount of gallons of gas times 20 miles per every gallon gets us to 620 miles? And how would we solve for G? Wouldn't we have to divide both sides of the equation by 20? And G in this case, is it on the screen? Not really. Goes into it 3, 1. He would need 31 gallons of gas. He would need 31 gallons of gas as he rolls down the highway in his pickup truck. Okay, one more. Parker. You thought I forgot you, Parker. Nope. Here we go. Parker, being the generous soul that he is, he decided to buy gifts for every student in the school. And imagine there's 62 students in the school. And he ends up spending a total of $310 on these gifts. Now the question is, how much did Parker spend on each gift if all of the gifts cost exactly the same amount of money? He bought gifts for 62 students. He spent $310. What is the cost of each individual gift? Well, isn't that really 62 groups of an unknown amount of money that gets us to $310? Yeah. So maybe this amount is 8. Maybe this amount is 2, I don't know. But the amount of students times the price per gift should get us to 310. How are we going to solve this? What's the opposite of multiplying by 62? Isn't it dividing by 62? And if we divide both sides by 62, we're going to get an M value of 5. What's the label going to be? It's going to be $5. Parker's spending $5 per child on gifts. Okay, that's your lesson. If you have any questions, talk to me.